Okay, so today's learning objectives are, we'll touch upon the design processes, then design objectives, design constraints, design functions, design tasks, design alternatives. So what are these terms? What do they actually mean? So design process, anyway, we have already seen. Then design objectives. For any design, understand that there is a objective, or there are a set of objectives. Then there may be set of constraints that you face during your design or implementation. Then there are certain design functions, design tasks, design alternatives. So to understand that, first of all, let us take an example from computer science, our domain itself. Suppose you want to build a website or a mobile application, something like that. A client comes to you, or somebody comes to you and asks for a development of a websites, for example. Then what is the objective there? Design objective. So you want to design a website. So that website may be for some e-commerce application, maybe for our academic purpose, maybe for some banking website, or any application. So that is the objective. So what is the objective of the particular design? The design which you are going to do, the objective is design an interactive website for online purchase or e-commerce, isn't it? So that is the objective. So for any product, not only for computer science domain, any domain, whenever we are designing something, there will be an objective, isn't it? So there is a gap, there is a requirement. That is what we have already seen in the previous classes. We will discuss with the customers and other stakeholders to identify the need. Okay, this is what is required, this is the product required, this is, say, a new mobile phone with so and so features. Okay, so that is the objective of, in our case, the objective is to design an interactive website for online purchase. Then design constraints. So design constraints may be there. So constraints may be maybe time constraints. Sometimes you will have to design this website within the specified time, maybe 1 month, maybe 2 months. Nowadays, we are all infected with, we are all struggling with coronavirus. So many countries are trying to design vaccines for that. So there is a time constraint, because as early as possible, many countries have set the deadline by the end of this year. So that is the constraint for design. So those who are working in that medical field, designing or working on experimenting on the vaccine, or trying to invent vaccine, they have a time constraint. Sometimes we will have financial constraint. Okay, I can spend only this much money for this product. Within that limit, you should devise a better or best possible design. Sometimes legal constraint. So sometimes the legal issues may vary from country to country. What is allowed in India may not be allowed in other countries. So in our country where we are living, in our locality, what is legally possible, what is ethically possible, ethical issues, so ethical rights also, ethical constraints also, what is ethically right, what is ethically not right, isn't it? So that is what design objectives. For any task, we will have an objective. For any project, any design, we will have objective, and they also will have certain constraints involved with that. Then design functions. See, design objectives are there. So we want to design an interactive website. So that is objective. Then what is function? Function, little bit of when we look at the implementation, what are the issues, what are the features that this website should have, isn't it? It should take user input, user should be able to interact with it, user authentication should be required, isn't it? So all those things are, or safety should be there, security should be there, it should be simple, isn't it? It should be user friendly, interface should be there. They are all functions. Okay, for the design, these are the functions. So objective is, we want to build an interactive website. Functions, what are the features or characteristics that we would like to associate with our design. Now, what is task? Okay, with the corresponding design, there is a task. Say we want to have security. So how will that is a function, secure user login. Then task means, how will you achieve that security? Maybe user authentication, maybe by comparing username and password, okay, or maybe using your facial recognition or biometric features, isn't it? That is a task. Okay, the task associated with function. The functions are part of objectives. Objectives the broad picture of what we are going to design, isn't it? In our case, it's a website. Then functions mean what are the specifics, what are the features, what are the characteristics that we would like to associate with our website or our mobile application or any hardware or software product that we would like to design. The task is how we are going to implement that. What are the at an implementation level, like authentication, how do you do that authentication? So we need to have comparison of username and password. You need to have a comparison of biometric features, isn't it? Something like that. Then you have the term design alternatives. Of course, when we are designing, we will have choices to make, right? So choices, and finally we will, okay, for a website, how the design should be, what is the platform should be, what is the tool to be used, what is the front end, what is the back end, what is a database, isn't it? Database, if it's a relational database, then you can use MySQL. Then it is, if it is non-relational, you can go for MongoDB, something like that, isn't it? Then you can use Java framework, you can use PHP framework, you can use Python framework, Python Django framework, or the JavaScript Angular JS, isn't it? Or Symfony or Laravel PHP framework. So what is that? What are the alternatives we have? What are the choices we have? What are the different options we have, isn't it? Then depending upon the customer requirement, customer feedback, by interacting with them, by literature, by reading the available literature, then we will identify what is the best platform. This is if I use this platform, I have these advantages. If I use that platform, I have disadvantages. So pros and cons of various options we should compare. Then finally we will decide that, okay, this is the best possible design that we can think of with the available information, with the available objectives, available constraints, functions, tasks. Okay, this is what we are going to do. And that is actually we will be doing something like a SWOT analysis: strength, weakness, opportunities, and threats, isn't it? So that then based on that, we will finalize a design and we'll go ahead with the design, then implementation, then testing, then finally marketing, all those stuff. Okay, so that is actually the objective of today's class. So we will go into details of this. So anyway, keep in your mind this example of website or mobile application, which is from our own domain, and try to connect these objectives, constraints, function, task, alternatives with this example. Is this clear? Any doubt? If you have, you may ask. Please type in the chat. Is it clear? Is the concept clear? Yeah, Aditya is telling clear. What about others? Yeah, many are telling it's clear. Okay, Riya, Sneha, Siddharth, Srived, everybody is telling clear. Okay. If anybody wants to repeat, I'll repeat. If any of the term, objective, function, task, or constraints, alternatives, if any of the term, if it is not clear to you, please type in the chat or switch on your mic and ask me. I'll repeat. Otherwise, we'll go into the details of today's class. Okay, so design objectives. Okay, so as I told, this is the most important aspect. So this is so here, look at that. A design objectives: design a portable drilling machine. This example is not from computer science domain. Design a portable drilling machine. That is the objective. Okay, so design objective, a feature or behavior that we wish the design to have. So some generic objectives are maybe to satisfy the need of the user or to reduce the cost. Sometimes, okay, to meet, I need a particular device. So that is what a portable drilling machine. So sometimes I would like to reduce the cost, a cost-effective drilling machine. Sometimes to reduce the complexity, a simple and easy to use drilling machine. Sometimes eco-friendly product, which is a sustainable one, right? So, for example, if you want to design a portable ladder, then these are the objectives. So what are the objectives? A ladder should be compact and portable. It should be stable on smooth surfaces, should stand safely, must be safe, relatively economical, so and so. So based on the objectives, you can have a structure called objectives tree. If you look at the construction of ladder, safe ladder means safe ladder, safe in the sense stable. You have two branches, safe, stable, as seen from the diagram, stable and stiff. Stable means again on floors it should be stable, on level ground it should be stable. Then stiff, then marketable. Then marketable means what? Useful, inexpensive, portable, durable. So useful means it should be useful both indoors and outdoors. Then electrical and maintenance aspect should be easy. So useful and portable, light in weight, small, transportable. So what I mean to say is that for any design, you can have a set of objectives, and based on that, you can have an objective tree, something similar to that. So keep in mind. Then design constraints. Design may have many constraints. As I told, constraint is a restriction on design. Okay, so functional constraints, say overall geometry. So this is the size, that is what we would like to have a size. Okay, this much, 1 feet length to 1.5 feet width, something like that. Kinematics, how it's about movement. What is the speed at which it should move? Something like that. Energy requirement. What is the maximum energy requirement? What is the maximum energy that it can utilize? So that's the constraint. So minimum energy, materials used, what are the available materials? So again, a constraint. Control systems to be used. Then safety constraints, what are the safety mechanisms that we should enforce? Quality constraints, what is the minimum quality required? Manufacturing constraint, time constraint. As I told, while designing, while implementation, we will have time limit. Economical constraints, this is the maximum amount I can. So I am a company owner. Okay, I can spend 50 lakhs or 5 lakhs for that, for this project, not nothing beyond that. Some legal and ethical constraints that vary from place to place. Okay, so constraints, objectives allow us to have wider choices, isn't it? Objectives, we can have wider choices, and constraints limit the choices. So here a constraint is portable drilling machine should weigh up to 1.5 kilograms. So that is we are actually reducing the design space. 1.5. If you want to keep the weight within 1.5, then actually the number of the alternatives are very less, because we'll have very less in the sense limited, because that we should use such a material so that weight is 1.5, something like that. Okay. So design functions. Design, this is about the specifics. The design is planned to do. So for example, the drill should work in high humidity. The drill should switch off if the load exceeds. Some of the functions can also lead to constraints. Say for example, maximum load. If you specify the maximum load, it can also be a constraint. So functions are the behaviors that are expected from the design. Okay, you can go through these slides. So introduction to design, functional design, and strength design. So that different types actually. Functional design means we are focusing on the functions. Say for example, watch, ballpoint pen, amplifier, software, etc. Strength design, we are here forces acting and environmental factors are critical. Say automobile, dam, crane, ship, rocket. So their strength is more important, or as important as function. So in the case of ballpoint pen and all, the strength we don't, because it should be as strong, as strong as that we should be able to hold it. That's all. Also, we should be able to write it. So nothing beyond that, isn't it? So functional design, strength design. The different types of design. Taxonomy of design problem. So we have already seen design taxonomy or classification of problem, design problems. So when we are designing a new artifact, design improvement problem by tuning the subsystems, changing some variables. So whatever we have something already, we modify to suit our requirement. That is design improvement. Design problem, all of a sudden or all together, right from the scratch, we design, invent something new. So design process, these steps, anyway, we have discussed that. Go through this once again. Okay, we can go through that structure design process. So these are the steps, clarifying objectives and all. You can do. So what is a series of design tasks in order? So establish a client's objectives first. Identify the constraints. Establish the specifications. Generate design alternatives. Model and analyze. Test and evaluate. Refine and optimize. Document the design process and communicate the completed design. So this is a diagram with the same terminologies as a flow chart. We can go through that. So different stages in the design process, we have discussed that. Analyze the situation, write a brief problem statement, research the problem through brainstorming, discussing with our friends, colleagues, stakeholders, write a specification, problem description, work out possible solutions, select a preferred solution, prepare working drawings, construct a prototype. Prototype is actually we are starting the implementation. We are constructing a workable model so that we get the real feedback. Like we can decide how our design is, how good our implementation is, how good the expected features are they working correctly or not? Or if it's not working, we can go back to the design and we can modify the design. We can reinvent again. So test and evaluate, write a report finally. So this is the flow of this overall phases in the engineering design process. Whatever we have discussed in a pictorial format, you can go through that. Due to the in the interest of time, I'm skipping this. Product problem identification, that is a big so sometimes, you know, the requirement may be something like, I need something to lift a very heavy box, or somebody might say, I need a container for 25 liters of mineral water. So one cannot proceed much with such vague problems and identification. Sometimes the requirement may be spelled in a vague and general fashion, isn't it? Something like this. So, but to start the design, to go ahead with the design, as a design engineer, we need something very specific. So clear problem definition is critical to the design. So what we should do, clarity on the problem can be obtained by questioning. We'll ask further questions, isn't it? So when somebody might say transportation of 30 liters of mineral water, what is the vague definition that he's telling? A container is to be designed, but to start with the design, from engineering perspective, we must get clarity. So we'll ask more questions. Why a container is required? Something else you can use. Where is it to be used? How much weight it's to be transported? Is the water in one or more bottles? What is the size limitation? Is container lifted, pushed, or turned? If so, how you are planning? Are the containers transported in a truck? Has the truck any provisions for this? All those issues, all those questions we will ask with the customers, and we will, from the based on the answer, we will decide something. Okay, this is the best design which meets all these requirements, isn't it? So what we are doing, we the design engineers are transforming a vague requirement into a specific requirement. Okay, that is the job of a design engineer, by asking so many questions, so many relevant questions. Okay, then we will define the problem. What is actually designed to have a toy for 3-year-old? What are the factors to be taken into consideration? Some say safety, ease of use, and so many things. By considering all this, we will finally define the problem statement. So that is the problem. Is a specific, like I want to have a website. I have to have a secure and safe website. I want to have an easy to load website, isn't it? I have to have a mobile application. I want to have a native mobile application. I want to have a hybrid mobile application, isn't it? Something like that. We will define the problem. Okay. Design functions, already we have seen that. Yeah, design functions. So functions are classified as basic and secondary. Basic functions are there. Secondary functions are there. What is basic function? Say, for example, a portable drilling machine. Basic function is the main objective of the design. Drill concrete. So it should drill concrete also, isn't it? So when we are thinking of designing a drilling machine, what is one function required? Basic function. It should drill concrete. We should be able to drill concrete with that drilling machine. But associated with that, there may be noise, there may be heat, some unwanted secondary function. They are also classified as functions producing heat. Heat will be generated when you drill concrete. When you drill concrete, noise will be generated. So generation of noise, generation of heat, they are all secondary functions. They are associated with the main function, primary function, and they are actually unwanted secondary functions. So design functions can be primary functions and secondary functions sometimes will be unwanted. Then design means. This is another term, design means. It's a way in which a design executes a desired function. Say, for example, the function of a bicycle brake is to stop the wheel when applying the brake lever. So how it is doing? Means of frictional force between a rim and brake part. You have a brake associated with the cycle. So how it is working? So what is the function? Function is when you press the brake, cycle should stop, isn't it? The movement of the cycle should stop. So that is the function. But how you achieve that? That is through the frictional force between rim and brake part. That is a design means. So this is actually how we are implementing that, isn't it? Maybe sometimes in our computer science domain, maybe which algorithm we are using, what is the mechanism we are using. Say, for example, I told user authentication. You want to verify a legitimate user is logging into the website. So how will you do that? Just by user authentication, just by using username and password. Every user will be having a username, and every user also will be having a password also. Then we will compare the corresponding username and password is matching. If it is matching, we will allow that. That is called authentication. So that is actually the means, the mechanism by which we implement that. Okay. The function of a speaker is to produce sound by means of electromagnetic induction. So design functions, function means tree. You can think of some function means tree. Yeah, so this here the function is ignite the cooking gas. You are all familiar with the cooking gas. So ignite the cooking gas is the basic function. So mean in pink color and function in white color. So you can ignite through either through flames or through spark. Now flame, how can you achieve flame? You can use matches. You can ignite gas. You can ignite petrol. So they are all functions. They are all functions. Okay, then the corresponding means. Okay, then function spark, electric spark, a piece of sparkle. So what is this? This is a function means tree, basic function associated some functions. How we are achieving that function, that is the mean. Okay, means of doing that. So this is the functions means tree. Now specifying functions. Okay, functional needs are to be well defined for achieving the design objectives. So for this we have to specify the function. In engineering term, this is called a specification. So we engineers would like to have the specification of a product, isn't it? So anything, what is a minimum voltage, what is a maximum voltage, what is a maximum watt, what is anything, isn't it? The value milling, for the example of drilling machine, what is the wattage, what is the output, what is the standard operating procedure, what is the performance level, it should drill concrete, something like that. So that is specification of functions. Then defining the design space. Design space is another term you must remember. What is design space? This is the imaginary space for design alternatives for a problem, for a particular problem. For a website development, for a mobile app development, I have so many choices. I have so many possibilities. So all these possibilities, I can go ahead with the Laravel framework, Symfony framework, Java framework, Python framework, isn't it? Or backend PHP or Ruby or anything I can use. So these are all the possibilities I have. So whenever I want to think of, whenever I would like to design a mobile application, I can have a native mobile application, I can have a hybrid mobile application, isn't it? So which is required for my case, so I will decide. So that is the design space. So design space is nothing but a set of alternatives which you can think of considering. Then by taking one after the other, you can have a SWOT analysis and you can finally decide on what is to be done. So that indicates actually the vastness of the possibilities. So this may be taken as a homework. So this is a headphone. So suppose you want to design a new headphone. Okay, identify the set of objectives, identify the set of constraints. Constraints may be something like imaginary constraints also, isn't it? You are a team working on the design. What are the constraints? Then what are the functions that you would like to associate with this? Okay, this is a homework. All of you should do this, and all of you should discuss and submit in the next class. Okay. So this is a headphone. What are the objectives? What are the constraints? And what are the functions? So this is a helmet again. What are the objectives? What are the constraints? What are the functions of designing a helmet? So that means that you are required to design a helmet. Okay, some of you would have already used that. Some of you would have seen somebody using that. So based on your experience, based on the knowledge, or you can talk to the people who are already using it. You can take the feedback. How do they feel? What is the improvement that they would like to have in the present design? Based on that, you can have a set of new objectives, isn't it? Then set of constraints, set of functions. What are the functions that you would like to associate it with this? Then task means how you're going to implement all those things. Then this is a extension box. Again, what are the objectives? What are the constraints? What are the functions? All of you should do it separately and you should discuss with me. Okay, so this is taken as a homework. For these 3 or 4 features or cases, design cases, you have to identify objectives, constraints, functions. So same function, different forms. Mobile land phone or mobile phone in different format. Pen, different types of pen, but same function. They are all used to write. So different types of hats. All the purpose is the same. Okay, so that is the design space. So defining the design space, you can think of brainstorming. Brainstorming means you consider all possibilities. You discuss with your friends. You listen. You actively listen to them. You listen to them. Listening means reading or listen to others when they speak, isn't it? So based on that, you will get a lot of ideas on how to go ahead. What are the design alternatives that you can think of it, isn't it? Based on that, you can have a design space. So again, you can read that. So what makes a design problem open-ended? Design problems are open-ended because they typically have several acceptable solutions. So sometimes we cannot say that one is better than the other, isn't it? But one is better in every aspect. Say, for example, you would like to go purchase a mobile phone, isn't it? You will go to a shop and the shop owner will show you n number of models, isn't it? But can you say that one model is best over others, or better in all parameters? Sometimes you may have better camera with one model, sometimes you have more battery with the other model, isn't it? So many features, it may vary. So that is what typically more design will have several acceptable solutions depending upon our specific need. What is that I need? What is my requirement? Based on that I can decide, isn't it? That is what customer requirement. To satisfy the customer requirement, you can go ahead with a particular specific design. So that is why open design problems are open-ended. Sometimes you need to think outside the box, isn't it? Sometimes you need to, everybody is thinking in one direction, but in order to have innovative ideas, you should think differently, isn't it? You should have innovation. Think of crazy ideas that are non-workable at the first thought. When you think initially, the idea may be non-workable, but when you think more and more on crazy ideas, sometimes what will happen? You may have some interesting idea, some novel idea, and that will be a turning point in your career, isn't it? So that is the importance of thinking outside the box. Yeah. The quality function deployment is nothing but engineers and scientists are comfortable with the units and quantities, but the customers are ordinary individuals who express their needs only in simple terms. Say, for example, I need a silent air conditioner. That is good, but how to convert this into engineering specification? Silent air conditioner, what is the maximum sound, what is the minimum sound that the air conditioner should produce? And here the customer is telling good air conditioner. What is that goodness, isn't it? Is it in terms of amount of electricity that it consumes? Is it in terms of the chillness that it provides, isn't it? So converting the customer requirement into engineering specification, that is quality function deployment. So evaluating and choosing a design, so design evaluation, SWOT analysis you can do, strength, weakness, opportunity. So that means when I design a website, I have n number of choices. So I will do a SWOT analysis. So I will consider the strength of each proposal. I will consider the weakness of each proposal. I will consider the opportunities with each design. I will consider the threats if I go ahead with a particular design. So strength, weakness, opportunities, and threat, that is SWOT analysis. That is how you evaluate and choose a particular alternative. So design strength, what are the ideas advantages? What can the idea be successful? What are the current existing idea resources? How others may see the strength of the idea? All these questions you can ask yourself, or you can ask your team members, you can ask your customers or stakeholders, and based on the answers, you can give some weightage to a particular design as the strength parameter. Okay. Now, like design weaknesses, how can the idea be improved? What are the weaknesses? How can prevent the idea from a success? Anything which might prevent this idea from implementation, from being a success? How do others see the idea in terms of weaknesses? Then opportunities. What opportunities does the idea have in the market? So if I go ahead with this idea, with this implementation, what are the opportunities? This may be a striking, innovative, new model. So what are the opportunities that I foresee if I go ahead with that? Then threats. What are the obstacles that face the idea? What are the financial needs? Okay, idea is good, but it might require a lot of money which I cannot fund, which the funding people may not be able to garner. Then it's very difficult. It is possible to quantify this to compare design. Always remember that no design is final. Designs are always evolving. Based on the feedback, based on the SWOT analysis, designs are always evolving, isn't it? So design process, already again repeating the same thing. Overall design process, you can go and read that. Okay, identifying the customer needs, market analysis. So establishing function, again a recap of that. Difference between function. What is function? So the difference between being asked to design a car suspension system and designing a car. Designing a car is an objective, and car suspension system, that's a part of a car. So that is a function. Brake system, electric system, isn't it? They are all different functions associated with the design of a car. I want an economically viable car, so that's an objective. So different functions: suspension system, brake system, electrical system, electronic system, isn't it? So many subsystems are associated with each design. Okay. So in the design, sometimes for this example, a client may ask for a traffic light system to be placed. Problem focused design and solution focused design. If this is solution focused design, then somebody says that traffic light system, they require a traffic light system at a particular junction, we will go ahead with designing a traffic light system. But if the designer is problem focused one, or he's interested in a design, problem focused design, what he will have thorough analysis, he will discuss with the customers, he will take suitable feedback, and finally he might understand that an underpass may be a more viable solution to alleviate the traffic issues there. So rather than having a traffic light installed there, it is better to have an underpass, and that will solve the traffic problem. So that is what problem focused design. So solution focused design is you have a solution already determined. So predetermined solution, you will go ahead with that. But problem focused design, you will try to understand what is the problem. And then what are the alternatives? You can go ahead with traffic light. You can have an underpass, which is best suitable for this case, and we'll decide that. That is the problem focused one. Okay. Yeah, another one is a lawn mower example. Lawn mower which cuts the grass. Okay, if so, instead of lawn mower, our focus should be the method of shortening the grass. Then we will come up with a different design. That is what it is told. Instead of a lawn mower means we will have the idea of a lawn mower, how it works, and we will have the structure. But instead of designing a lawn mower, you should focus on shortening the grass. Just like in the previous example, solving of traffic issues should be the major focus. Okay, so that one may limit your imagination and creativity, while the other may give you free reign for creativity. That problem focused one will give you a lot of alternatives. Then task specification. Okay, I told you how it is. Lot more example, you can read this. Conceptualization, solution concept, alternative solution. Freehand sketches for producing a series of alternatives. So initially we'll draw a lot of sketches, and the alternatives need not be worked out in detail in this stage. Then evaluating the alternatives. So I discussed, no, that's SWOT analysis. Decision must be made as which one or ones will enter the next implementation phase. Okay, based on this SWOT analysis that we have already discussed. So embodiment design, product that is being designed begins to take shape. This is where it actually begins to take the shape. Okay. Then the stage is separated from, new technologies can replace old one based on the exact same concept, isn't it? So whatever best, you can think of that. So traffic light system also, if you want to install a traffic light system, that red, green, amber light, that is always there. That is a basic concept of the traffic light. But as per the current technology, what are the technological provisions that we can use? Maybe an intelligent traffic system which can automatically sense the traffic, isn't it? Or you can use a timer. Using the timer, you can change the light of a traffic light system. That is a conventional one. But you should be aware of the latest technology, isn't it? Then only you can have a better design. Latest technology may be artificially intelligent traffic light system, where it automatically senses how many vehicles are in queue, and based on that, it switches a particular light on, isn't it? So that the designer should be well aware of the latest trends and technologies while designing, isn't it? That is where engineering comes into picture, isn't it? This 4 years of engineering, you'll add a lot of engineering skills, isn't it? So design skills, engineering skills will make you a design engineer. That is what we already told in the first class, isn't it? So yes, traffic light system, I told this example. Analysis and optimization, that is where we do the detailed design, how it works, how do I meet, am I meeting the requirement, can I go ahead with the design, or should I make some modification here and there, so that I can meet the customer requirement, I can meet the constraints, isn't it? I have certain constraints, financial constraint, legal constraint, manufacturing constraint, functional constraints, ethical constraint, isn't it? So with all these constraints and the set of objectives, functions, tasks, which is the best one? So that is where, that is what we do in this analysis. And then we optimize, we will go back to the design. If some changes here and there required, I want to cut the cost further, because now it costs 6 lakhs, but I want to make the cost in 5 lakhs. So we'll go back to the design, I will modify here and there, so that my budget is still within the 5 lakhs budget, 5 lakhs cap. Okay, so that is optimization. So analysis requires a concept to be altered or defined, then reanalyzed, so that the design is constantly shifted between analysis and synthesis. Experiment is where you work on this experiment stages, and during design requires that a piece of your hardware is constructed and tested to verify the concept and analysis of the design as to its and analysis of the design as to its workability, durability, performance characteristics. Okay, so 3 techniques of construction are available. So first one is mock-up. The mock-up is generally constructed to scale from plastics, wood, cardboards, and so on. So from this cheap material, plastics, wood, cardboard, we'll try to construct a model, and we'll try to analyze it, isn't it? That is what is mock-up. Then another mechanism is model. Model is the representation of the physical system through mathematical similitude, mathematical modeling. So a true model, there are 4 types of model. True model is an exact geometric reproduction of the real system, and so adequate model is constructed to test specific characteristics. Distorted model purposely violates one or more design conditions. Dissimilar models bear no apparent resemblances to the real system. Okay, these are different models available. So based on the requirement, you can finally decide. Then prototype is actual implementation. The prototype is a constructed, full-scale working physical system. So how we should go ahead? One should first deal with the mock-up, then the model, and then finally the prototype. Okay. So then finally, the marketing. Marketing means specific information. You have designed or developed a product, then you can go ahead with this, and you can have a report containing the detailed description, and you can distribute this to all stakeholders. You can have a flyer containing the list of the special features that your product has, and you can distribute this to all the stakeholders, and you can have maximum publicity so that they will buy your product. Okay. So this model, I'll talk about the model once again. 4 types of models. So true model is an exact geometric reproduction. So what is that actually we need really? So this is true model is an exact model. The length, breadth, everything same, built to scale and satisfying all restriction imposed in the design parameters. Built to a true model. Adequate model is constructed to test specific characteristics. We may not consider all characteristics of the design, but important characteristics we will consider, and those characteristics we will evaluate. Then distorted model purposely violate one or more design conditions, but this violation is required because when it is difficult to satisfy the specified conditions. So this required conditions are impossible to achieve, then we'll have a distorted model. Dissimilar model bear no apparent resemblance to a real system, but through appropriate analogy, isn't it? This is a model, but this is a different thing we want to have. But sometimes there may be a speed, maybe a rotational speed, maybe some frictional force, something that may be similar in this model as well as that model, isn't it? Something, or the stress, the strain that we would like to analyze, isn't it? Maybe same. So we can have a dissimilar model also, because stress is same, or force is same, or speed is same, acceleration is same, or some feature is same. So even when the model is dissimilar, we can use that model to study how the model works with a particular feature. So based on our requirement, we can go ahead with that. So prototype, then finally prototype is actual implementation. So finally prototype, before that you have model, then first one mock-up. Okay. So I think time is up, 10 o'clock. Yeah, so I'll stop now. Yeah. So